Hey everyone, I just want to welcome you to our first developer office hours. This is our inaugural one, and we're going to be covering understanding Algorand smart contracts. Like with me is Ryan Fox and Russ Simo. We're going to go through some slides, go through some examples, then we're going to do a Q&A, and people can ask questions. We'll unmute you, but meanwhile, during the whole presentation, you can also just use the questions box in the panel to ask as many questions as you want, and Ryan and Russ will be handling those while I do the presentation piece. Everything you're going to see today is available for download, but I will caution you, some of the code that I'm going to show today is for learning only. Do not use in production code because it does not have most of the checks that you would want in them for making sure that you don't lose your money. So let's do keep that in mind. This is I'm going to show you a bunch of snippets of code, and they are for learning experience only. We're going to be discussing the smart contract language, and that is TEAL. We'll also talk a little bit about PyTeal, and later on in future events, we'll be covering things like how to build a digital exchange, how to build crowdfunding applications. Next week's session, Ryan will be running, and we'll be covering how to use the sandbox environment. So that's next week. So if you haven't signed up for next week, make sure you do that. So without any further delay, I think let Ryan and Russ say hello, and then we'll get straight to it.
Hey, good morning, everyone. I'm Ryan Fox, and pleasure to have everybody here. Please use the questions tab to ask your questions. We will be monitoring those and answering the questions throughout this presentation. Thanks.
And good morning, everybody. My name is Russ Festino, developer advocate, and I look forward to the questions. I'll be working with Ryan there, looking at the question queue. If you have it, use that. Otherwise, if you're like on an Android device, the chat queue will be fine. Also, I'm going to launch a quick poll here in terms of the experience level. Let me know if you guys see that okay. But it's only one question we're going to run here. And for attendees, what is your experience with blockchain? Check all that applies. So number one, brand new to Algorand blockchain, period. Brand new, but have some experience with Ethereum. Brand new, but have some experience with another blockchain. And I have actually published an Algorand blockchain solution, or I have actually published another blockchain solution. So the results are basically 44% are brand new to Algorand blockchain, period, and another 22% brand new, but they have some experience with Ethereum. And we did have some folks here that have published, Jason. So we've got about 17% for Algorand and another 17% for another blockchain. So you can take it away. Thanks.
Thanks, Russ. All right, yep. So let's go ahead and get started. First thing I want to cover is what environments do you use the Algorand smart contract language, and it has to do with our smart contracts. And we have basically two. Currently we have, and we're continuing to improve this technology, and there's going to be some future things that are coming that are going to even expand on the abilities of what we currently have. But currently we have two: stateless and stateful. When you think about stateless, think about they're used to approve spending transactions. You submit the TEAL code as part of the transaction. It's executed on the node at submission to verify whether it's going to be approved or not. Stateful, on the other hand, these are contracts that live on the chain and that you initiate with a transaction. And we'll see some examples of we're going to spend most of our time in the stateful variety. Do have an escrow example. If we get time, we'll show that. But by and large, we want to spend most of the time in stateful applications because those are really the backbone of applications on Algorand. If you're familiar with Algorand, we have something called assets. Anytime you create an asset, it's kind of like an ERC20 token where you create it. It's a one command line creation, and you can set parameters for it. You get back an asset ID that's associated with that asset. Well, when you do a smart contract, a stateful smart contract, when you create it, it's a transaction to create it where you upload the code, and you get back a contract ID or application ID. So we call them applications on Algorand. That is essentially what stateful contracts are. Now, what's really nice about both of these pieces of technology, they're combinable with other pieces of technology. Like I can do atomic transfers with a stateful call. So why a stateful call can't approve or deny spending transactions, if it's atomically grouped with a spending transaction and your stateful contract fails, then so will the spending contract. So there's ways to make it function as an approver of a transaction. You can also combine it with assets. You can look up asset values, that kind of thing. We'll cover some of those things later. But and then you can also combine stateful and stateless contracts. Many times you'll do that. You may have a DEX that has all of the digital exchange that has one app to track all live open orders, and then using escrows to hold funds as people want to fulfill a limit order, for example. So, but moving along, these are, I'm going to try to move kind of quick through the first couple ones, just because they're pretty much review of what the architecture looks like, and you can actually see these same diagrams on our developer documentation page. But the first one is escrow. There are two forms of stateless. There's basically a contract account and delegation contract. And what the difference between those two are, starting with the escrow or contract account, is all it does is you write a piece of TEAL code, you compile it, it gives you an Algorand address. You can take this address, and any account on Algorand can send funds to that account, whether they be algo tokens or assets you can send to the contract account. Anybody can do that. But for any of those assets or algos to leave that contract account, it has to pass the TEAL logic. So that's what we think of as an escrow, right? So you may say, okay, I want to load up this escrow and let this particular individual take funds out this many funds out once a month, or something along that lines. That you could do that with a contract account. So it's and you can also make sure that splitting of payments is enforced, all kinds of things like that. So that's the escrow version of where the TEAL is being used. When I look at Delegate works fairly similar, but you're not using it as the holder of funds. What it allows you to do is delegate your signature authority, which means you have this piece of TEAL code. Some account signs that TEAL code and says, I approve anybody using my signature as long as it fulfills this logic. And so you think about how that would be used as you go, okay, I want to let my power company take X amount of tokens out of my account once a month. So I'm going to sign a piece of logic that they can use to submit the transaction at a later date. That's a delegate signature. And that's implemented in TEAL as well. You can see where the gated logic is. You sign the logic is used later to sign the transaction, and that logic is tested at the time they submit the transaction. In both cases, though, the TEAL is supplied when you're submitting the transaction. All right, so then we have this new thing called stateful contracts. Essentially, we tell people they're used for writing global and local state. Now, what does that mean? That means I can store a set of global values for the contract itself, but I can also store a little bit of data for any user who options into that contract. And we'll talk about the sizes of those in a little bit, but you have global and local state. That's what we mean. So for example, we wrote a crowdfunding app. We track the total raised money in the global state. We track each individual user's giving in their local state. So if the fund wasn't successful, they could get their funds back. Their donations back. So that's how we would do that. Now, the way stateful contracts are written is actually two programs. There's an approval program and a clear program. And we'll talk about what each one of those is used for in just a moment. But in order to make these things trigger, one of these two programs will trigger based on a new type of transaction on Algorand called an application transaction. Now, an application transaction will trigger one of those two pieces. We have a bunch of subtypes of those application transactions, and that's what these are. These are the individual subtypes that are used to communicate with the smart contract. And let me give you a brief overview of what each one of these does. The no-op is a generic call to the stateful contract, and it's probably the one you'll do the most in your application. because the others are situated around optioning in or creating the or updating or deleting the end. All right, so opting in with that particular type of transaction that says, I want to opt into this contract. Now, let me make one caveat to this. You do not have to opt into a smart contract to use a smart contract. The only time you need to opt into a smart contract is if that smart contract is going to write local state for that user. So I can have I can have a stateful smart contract that has just global values, and anybody can use it and call it with a transaction without having to opt in. And the reason that this is because technically the values, when you option into either an asset or a stateful smart contract, it's taking ledger space underneath your account, and that's for local storage, and that's why we do that. There's a transaction for deleting the application and also updating the application. Now what that means is I can deploy a smart contract and later on go update it. And that's important to note that someone else can update your application too, unless you code to make sure that they do not do that. All right, and in a lot of cases, the boilerplate, if you look at the boilerplate that we have on the website, we just don't allow people to update the application at all. But it is an option, so you need to be aware of it. Then we have these two strange ones, closeout and clear. Closeout is, think of it as an orderly shutdown of me leaving a contract. It can fail, so I can be denied leaving the contract. And in that case, any local state that I have in that contract will stay in my account. The only way to not, so that's if you're going to do the orderly exit from a contract. Everything up to this point is called what we call the approval program. It's the most important program you'll write for the for the stateful contracts. The clear program is I'm one out of this contract, and this call cannot fail. So no matter if the logic passes or fails, the call will still happen, and the person will be cleared out of their local storage will be cleared out of that particular stateful smart contract. So those are the basic six types of transactions that you'll issue against a stateful smart contract. You can do these with Go command or the command line tools or any of the SDKs, and we have examples of doing all of those. So those are the basic types. These are the two programs that run on a stateful TEAL program. Okay, so both of these contract types are written in a language called TEAL, which stands for Transaction Execution Approval Language. Now, what this is a bytecode-based stack language, which means we have a stack engine that's running at certain places, and I'll show you where shortly, that just contains a stack where values are pushed on the stack, operators are used to operate on those values and pop values off and push return values on. And while I know this sounds somewhat complex, wait till we get to a few examples, and I think you'll see that it's not as hard as it may originally sound. But in addition to that, you can also write these in Python and compile them down to, we have an intermediate compiler from Python to TEAL, so then you can just write it in Python if you find some of it difficult. All right, so but in this particular talk, I'm going to go into some detail about what you can do in TEAL. And the same things, anything you see me do in TEAL can be done in PyTeal as well. We do have full SDK support for calling these things. There's over 70 opcodes. You can do things like access someone's asset balance or algo balance. Maybe you don't want to allow someone to trade in a particular token unless they own another type of token, like a security token, right? You can do these type of things using a stateful smart contract. You can read not only the current transaction, but if you have an atomic group of transactions, you can read all transactions in that group. You can obviously read global and local storage values, and in the stateless contracts, you can actually do signature verification. As I said, we have the PyTeal library as well. All right, so moving along. I'm going to explain what this runtime looks like, and we'll start with stateless because it's the simpler of the two in my opinion, but it's what we also started with. This was the first set of contracts that we released. Now, what you would have is that you have a transaction submission. As part of that, you pass the TEAL program, not only arguments for the transaction, but arguments for the TEAL program as well. So those are all going into your submission. On the runtime side of this, the node that you submit this to has a stack engine in it. It loads that TEAL program one line at a time and processes. And while processing, it has access to read a set of global variables, and it can read the transaction properties or a group of transaction properties. In addition to that, it also has the ability to read and write temporary scratch. So you've got this up to like 255 scratch spaces that you can throw values for temporary usage and things like that. And so net, that is the basic stateless architecture. I'm going to show you one more complex version of this just to give you an idea of some of the limits that are on it. So for example, you see where it says args. Those are the arguments that are passed in. Those are the arguments for the TEAL program. You can have up to 255 of those arguments. And those are just a byte array, right? Your program can only be 1,000 bytes long on the stateless contracts, right? And then you have access up to 255 scratch space slots. And these are some of the properties that you can get at. Like I can look at who the sender of a transaction is, the amount they're sending, those type of things. All right, so that's a high-level architecture view. Let's take a look at stateful, and it runs a little bit different. So in addition to passing transaction parameters and arguments for the stateful TEAL call, we also have two other things that you can pass in. One's called an application array, one's an accounts array. Why are those important? Well, the application array just says, I want my stateful contract to be able to read some other stateful smart contract when I'm running this. So what this allows, is this allows the me to pass in up to 2 additional smart contracts that I can, within my contract, I can go read their global state values. So think about maybe if I want to have an oracle out there and that every contract that I deploy uses that oracle, then I would pass those in per transaction in an application array. And it's very simple to do that. I'm going to show us a demo of that shortly. And then we have the accounts array. So as we said in stateful TEAL, you can read and write global and local storage. Well, not only can you write local storage for the account submitting the transaction, but you can modify up to 4 additional accounts. That's that accounts array. You have to pass those in per transaction. So you may want to modify these 4 accounts, the first transaction, another 4 accounts, second transaction, right? And then obviously you have the arguments array. Arguments are passed a little bit different in stateful than they are stateless. And you'll see, we'll have plenty of examples in the SDKs or in Go that show you how to pass the arguments for both of them. But from a runtime, this looks like this. Here's my runtime. It's actually sitting on the chain, and I have a stack engine. The TEAL program, once you create the contract, the first call to create the contract actually loads the contract onto the blockchain. And think of it as it's always there, and it's activated anytime you do an application transaction. And that's programs, because you have the 2, you have the approval and the clear program. And it's loaded on create and update. When you first create it, then you update it. And then you have the stack engine that's running at all times to process each line of it processes each line of the TEAL program, much like stateless does. The difference is I can now read global variables and transaction properties, same as before, but I also have a few more global variables that are available to me, like what's the latest timestamp from the previous block. I can read the current round number, that kind of thing. So you get a few more global variables. In addition, you get not only a temporary scratch space, but you get to be able to write the global and local state. All right, now what that looks like from a little bit more complex view is something like this. And so it's essentially that same architecture you saw before. And the only reason I leave this slide in here is because it gives you the limitations. Like you can have up to 16 arguments, and they can combine. They can be no more than 2K. You can include up to 2 additional smart contracts to read, and I can read up to 4 accounts. In addition, the global and local state can be, global state is 64 key value pairs. The key and the pair are limited to 64 bytes apiece. And if you're thinking, look at how many bits is that? That's over 32,000 bits. I know because I use that to do stadium seating, right? And then we have local state, 16 key value pairs, which are both both 64 bytes as well. That's the maximum storage space that you can use. When you create the contract, you have to specify how much space you will be using. And you'll see that when we go through some examples, because I'm actually going to walk through some demos. Okay, so moving along. Let's take a simple stack example. All right, so I have this little snippet of TEAL here. It says transaction amount, TXN amount, int 1000 greater than or equal. Okay, so how does the stack engine process this? Simply, the first command takes the TXN pseudo operator and pushes the transaction amount onto the top of the stack. That's the current transaction. What amount is this transaction's value? It gets pushed to the top of the stack. The next command uses the int pseudo operator to push 1000 onto the stack. So now notice my transaction amount went down and 1000 went over to the top. What the next command, the greater than or equal, what it does is it pops both of those two values off. It's an operator, and it takes two parameters. It pops both of those parameters off, compares the first to the second, and in this case does a greater than or equal to, and then pushes 0 or 1 back onto the stack. At the end of my program, I am at the end of a complete run of a program. What the TEAL code is looking for, the TEAL runtime is looking for, is there anything left on the stack? And if there's one positive value on the stack, then return true. If any other condition is the case, it will fail. Meaning, if I have more than one value left on the stack, if I have or I have nothing on the stack, then that's considered a failure. So it returns false, and the transaction will fail. So this particular opcode, greater than or equal to, if you look in our opcode documentation, this is how it's defined. And what you can see is it pops two values, A and B, and those A and B would be A would be transaction amount, and B would be int 1000. Those are pushed. Those are A and B. They are popped off the stack, and it pushes a uint 64 onto the stack. And its value is going to be 0 or 1 depending on if it's greater than or equal. That's a very simplistic opcode. A little bit more complex opcode is something like the app local get command. What this one does is it reads the local state for a particular account. And you'll notice, you see where it says mode application. One thing in between stateful and stateless, some opcodes are only available in one of the two environments. And the way you look for is you just look for that mode, if it contains a mode category. For example, if I look at ED 25519 verify, it says mode signature. That means it can only be used in stateless contracts. If I look at any of the app local get, app global get calls, these are all mode application because those are for stateful calls. I use this document quite often just to look at how many parameters it takes, and some calls actually return more than one value. In this case, like if you look at app global get, it returns a value. And this reads key A from state of current application, right? And it returns a value in this case. When you use this app global get ex command, it returns two values. It returns a 0 and 1 on the top, and then the second value would be the actual value it read. And the 0 1 just says the value existed or it didn't exist. So we have specialized versions of each one of those. You have complete string commands, concatenation, that type of thing. So there's a lot of opcodes available, but we'll continue on. All right, so for example, and like I said, we have plenty of these pseudo operators. Like if you look at int, with loading ints, you can use byte to load base 64 strings or strings. And you can see in this particular case, I'm using byte quote my string. And that just says, okay, I want to load this string onto the stack. And then in that particular case, I'm comparing it to the first application argument. The top one is using the adder pseudo operator, which is just as this is an Algorand address. And in this case, I'm comparing it to whoever's receiving the transaction. All right, so let's, then we also, you have full access to transaction properties. Like you saw me look up the transaction amount. There's a whole list of them in the developer documentation that you can get at, but here's most of them here, of all the values that you can pull out. One thing to note is if you're in we'll get to this later, but I'm using the TXN operator, but if I have more than one transaction, so I'm using, let's assume I have an atomic transaction, then I'm going to use the term, instead of TXN, I'm going to use GTXN and 0 for the first one, GTNX 1 for the second one, GTNX 2 for the third one, and so on. And I'll show you an example of that later. It's just a different way of getting at the same data. All right, so let's take a look at a quick demo. And so the best way to learn TEAL is to set up a quick environment and use our debugger, because we have a debugger where you can actually do this. Now, so what I have here is and all this code will be available to you, but I have a demo directory with several example pieces of TEAL that we'll go through today, and then I have a environment where I'm starting and stopping a private network. So for example, it's just a shell script. The code's available for the shell script, but all it does is use Goal to start a private network and a network template. That's all I'm doing in this terminal. In this terminal, I'm actually running the code. So the first thing I want to do is I want to create the app. And in this case, I'm creating the global TEAL example, and I'm telling it that I want to use one global integer. These are the how much global and local storage I'm using. This is my approval program. This is my clear program. Okay, that's all that line does. So if I create that app, you can see that it's issuing a transaction against my private network here, and it does it. And I also got this little command in here just to read the current global value, and the current value is a 1. So now to debug this, what I'm doing is I'm just calling. This is a stateful TEAL call. So this is the no-op call. This is the generic call. So when I go goal app call, and by the way, this is just pointing to my data directory and where my goal binary is. If you use these, you'll have to change your pathing, but that's it. And this is how I'm telling the application ID I'm calling. And this is an argument. I'm trying to pass it a string argument and also an integer argument here. And then it's from my account. And one thing I'm doing is writing the transaction out to a file, but it's what we call a dry run dump. This is so it can be used in the debugger. This does not actually submit it to the network. So it writes it to a file. You have to raw send it if you do this later. So it's kind of a temporary, don't submit it to the network, but write out what would happen. And so that's what dry run dump does. And so I can run this little utility called TEAL debug and debug that TEAL with that particular output file. It's a real nifty way to learn how to use TEAL as well, because you'll see what it does. So in this particular example, I'm going to debug that example. All right, so it's now waiting on me to open up the Chrome Inspect tools. And you can see right here, if you just type in Chrome Inspect, you may have to configure the port, but in my case, I didn't have to. So I've noticed some people have had to do that, but it's in a debug documentation. It's very simple to do. But if you click Inspect, you'll notice it launches the debugger. This is the debugger in the state that this particular contract's being ran in. And so if I look, this right here, the main thing when you're debugging, when you're learning TEAL, the thing that you want to look at the most is the stack. Right here, this is the stack, the same thing that I talked about earlier. So if I use the pseudo operator byte to load the string counter, you see counter gets loaded on the top of the stack. Then I'm going to say app global get. It says go get me that the counter value that's stored in global state, and it returned a 1. So that's what the value currently is. I then push another 1 onto the stack and then use the plus operator to add those two, which pops both of those off and puts the result of the combination of the two, which is a 2. Then I store that in a scratch space. Up here, you can see where I wrote the 2 in my scratch. Okay, then what I'm going to do here is just store that value back to global. So I load up the string counter again. Whoops, sorry about that. I load up the string counter again, and then load the value that I stored in Scratch, and then the app global put takes both of those, pops both of those off, writes the value in, and returns nothing. So it clears the stack. So my stack's empty now. And then the last thing I want to do is, so because I want this to return a value, else the transaction will fail, I have to put something like on the stack. And I could just put int1. But in this case, I just reload up the thing I've already, the current value, and it's one positive value, so it'll return true. That's the best way to learn how to use TEAL. Even if you're going to go use PyTeal, it's a good way to go through the exercise of knowing what's actually happening. All right, so I'll just play that out. And next thing I'm going to show is a branching demo, because what things that you can do is you can also branch in branch it. While TEAL is not a non-Turing language, meaning you can't iterate, but what you can do is use branching. We have 3 branching commands. You can branch on a test of a positive, branch on a test of a failure, or just branch without a check. And so I'll show 2 of those right now. All right, so this is I'm going to go back to my create app, and I'm going to comment this out, and let's uncomment the branching demo. Let's create that app. Okay, and then in the debug, what I want to do is comment this, and this is me cheating, by the way. All right, so let's debug that, and let's see what it looks like. Make sure I did the right one. Yep. All right, so loads back up, go back and inspect, launch the debugger, and you see this is some code here, right? So this BZ says branch on a failure. This B and Z says branch on a positive. And let me walk through it using the stack to explain it, because it's the best way. All right, so by the way, that Pragma version 2 just states that this is using TEAL version 2. All right, so first thing I'm going to do is I'm going to get the number of application arguments as a test. If I have 2, then I'm going to load 2, so both of those are going to be equal. That's going to return a 1 on the stack. If they didn't have 2, I would jump to finish and return right away. But in this case, there is no jumping because I did have 2, and this is a negative test. So it's basically checking to see if that was 0, then it would branch, else it's going to keep going. The second thing I'm going to do is load the byte string myArg. Did you remember when we passed the argument, we called it myArg? And then I'm going to read the first application argument, and it happens to be myArg. And if those 2 are equal, that returns a 1. Then I'm going to BNZ to the check second argument. If I didn't do that, the program would fail right here, because I would load an int 0 on the stack and return. But in this case, it's going to bounce over all that logic and check my second application argument, which just loads up this loads up the first application argument. And note that I'm going to convert that to an integer for use in my code. That's B to I that says byte type integer. And then that's all parameters are really byte arrays that are passed in. So it's just converting that to the value 1025, which is the value I passed in. And now this is so this is the value I have. I'm going to load 100 on the stack, and then I'm going to say greater than. So I'm looking to see if the current application argument is greater than 100. And if it is, then I'm going to bounce to finish, which it does. So it branches over the top of this code. If it had not had not been true, this would have returned an error, basically failed the transaction. And then here I'm just returning a 1, and it's going to return successful. So I load int 1 on the stack and return. So that's the branching demo. Okay. All right, so let's go back to the presentation. All right, so that was the state demo and then branching demo. Okay, some of the things that you have access to, I probably should have showed this while I was in the debugger, but you can look at, these are some of the global variables. You can get the group size, which is important because you want to, in some cases, you want to verify that only 1 transaction is being submitted or 2 transactions. That's what group size allows you to do. If you're using a stateful contract, you can get the current round or the latest timestamp. And your current application ID is whatever application ID you have. If this is the first time your code is running, your application ID will be 0. That is the only way you can know you're actually creating the application at that time. And you'll see logic in the next example I have that actually checks that to make sure that I don't execute code if I'm in the creation of it. And then you can do things like check the minimum balance, minimum transaction fee, that kind of thing. And access to the zero address, meaning the value is not set. We use this all the time. All right, so a couple other things. You can check the type of transaction. These are the known transaction types for Algorand, like payment transactions, asset transfer, and this application call that I talked about earlier. So that's APPL. And you can notice in this particular case, I'm checking that the transaction type enum, which is just what type of transaction is this? Is it int, which is application? So this could be int pay, int AXFR, and this equal just says, are those two equal? And it's just an integer comparison. Okay. I can check the subtype of that particular transaction by using the onCompletion. The onCompletion is a transaction parameter for stateful contracts that tells you which one of the subtypes of transactions are being initiated. Is this a no-op? Is this an opt-in? Is it a closeout, update, or delete? And that's very important for doing things like if someone tries to update your application, you want to verify that maybe an update application is only allowed from a specific sender. Then you can actually do that check. And you would use transaction onCompletion and then int update application equal, and then you would do a branch into some logic that handles that, or bounce over it if it wasn't that particular subtype of transaction. All right, moving on. All right, now as I said, you got group size, so you can actually one of the most powerful things to do with a stateful TEAL is the ability to do atomic transactions with other things. So I may have 3 payment transactions, or I may have a payment transaction and answer transaction combined with a call to a stateful contract. Those are all done atomically. So I could say, okay, if the group size is 3, then we're good. If it's not, I'm going to fail. And then that will cause those other 2 transactions to fail on Algorand, so it's a nice feature. You can also check the type enum just the same way I showed earlier. One additional thing to note here is notice I'm using the GTXN 0 and instead of TXN. This is telling me to get the group transaction zeros type enum. This is the second transaction and this is the third transaction. So that's the nomenclature you want to use to address those. And so from a demo perspective, let me show you what this looks like. All right, so let me go back to my create. Go to my create, and I'm going slow. All right, so let's create that one. You'll notice I'm just stopping and starting the network every time. All right, so I'm creating an atomic one. And I'm going to use this debug atomic. Ryan, Russ, are you guys getting questions?
Yes,
yep,
we are.
All right, well, just hang tight. I may have to skip one of the last demos just because we're running low on time. But all right, so let me run debug atomic. Now I'm going to really quickly just touch on this file right here. This is you can look into sample code when I give you the link, but all this is the goal commands to group a bunch of transactions together. And then in here, when I run the debugger, I specify which transaction specifically I want to make the main transaction I'm debugging. All right, so if I debug that, all right, so it's creating all the transactions and it launches it. Go back to inspector, and I'm going to inspect that. And you can see here, in this particular case, I'm running only 2 transactions. And you can see GTNX is 2. You can look at my globals here, down there. The transaction I'm debugging is set to the TNX contract. But on the stack, first thing I'm going to do is I'm going to load up int 0 application ID. That says, am I creating the contract? Well, I'd already created it, so this is obviously going to be false. So since those are not equal, if they were equal, I would bounce to creation, which just returns. So it's not creation, so I'm going to check the group size to make sure that I have the right number of transactions. The global group size is loaded with a 2. I'm expecting to, so I equal those. We're good. It still has a 1 left on the stack. I'm going to check that the first transaction is a smart contract call, and it's got 6 and 6, which means those are equal. And then I AND those two together. And you'll see that that just gives me back a 1 on the stack. Then I'll check the third one to make sure it's a payment transaction. The second transaction, make sure it's a payment transaction. Its type is 1, so those will equal. And then we AND those two together. And then the final thing I'm going to do is check the pay transactions amount and verify that it's over 10,000. So I load the transaction amount up. Its value, I'm checking to see if it's greater than 10,000 microalgos. And in this case, it's 50,000. It is. So in that particular case, I'm ANDing those two together, and then I'm returning. And so it returned successful. Now, what I will tell you is, like I said earlier, those snippets of TEAL are just meant for learning. Do not use those, because I do not have enough checks in those to make them safe. And I'll give you a link to some of the stuff that you need to be paying attention to make things safe. But okay, so let's move on. Not only can you do that, but I can do things like check an asset balance. So remember when I told you pass in this accounts array? Well, you can actually specify an index into that account when you're looking for things like their local state or what assets they got or what balance they got. So in this particular case, I say, okay, the sender of the transaction is int 0. That's the first level in that array. Int 1 would be the first account in the accounts array. Int 2 would be the second account in the accounts array. So in this particular case, this represents the index into that array. And so int 2 is just right here, is just specifying the asset ID that's returned when you created the asset ID. So I'm going, okay, let me check to see it, and then I'm using the asset holding get operator. Opcode, all it does is you can return a couple values, but one of them is asset balance. So I'm saying, let me get the asset balance for the sender of this transaction for this specific asset ID. And because that call returns 2 values, I'm not interested in the first value, so I just pop it off the stack. I'm just assuming they have the asset. If they don't have the asset, it'll be a 0 on the top of the stack. So you can BNZ off of that. And when you do any of the branch commands, it automatically pops the last value off the stack, so which is nice. And then I'm seeing if they're loading int 1 onto the stack and then doing a greater than or equal to. What this logic just says is, hey, if they have greater than 1 in their balance for this particular asset, then they're good. This logic will pass. You can also read global state from another contract. So you can't write it, but you can read it. And those are the 2 contracts that you can pass in the application array. So I can go read the global value for the master contract, and I want to use it to derive some global value that I'm using in my contract. That's possible. I was going to show a demo, but I think we're running out of time, so I'll probably stay away from that one for now. Reading and writing local state. This is going to be a fairly complex looking slide, but I think hopefully it'll make sense. When you have a call to the stateful smart contract, as I said, you're passing in the accounts array. And it's technically 5 elements. Int 0 is the sender of the transaction. Those 2 are the index 1, 2, 3, and 4 into the array. All right, so these are some commands that actually write to the local state values. So I can write my amount given for the sender of this transaction, the amount they sent, and put that into their local state. I can also get that value for the sender. Notice that you got where I have the comment sender in those first 2 snippets of code. Well, from a standpoint, this allows me to read and write local state for up to 5 accounts, the sender of the transaction plus the 4 to send in, which is really nice to be able to do and may be necessary. For example, if someone gives you a delegate piece of logic that you fulfilled, and you're using a stateful contract to track that order, and it's in their state, the stateful smart contract may need to go into their state to clear it. So that's one way that you can see that being useful. All right, so it allows you to modify more than just the state of the sending transaction. In addition, this last piece of code, it says int account. I'm looking at the first account in the accounts array that I passed in, and I'm going to look up its contract ID, meaning I can actually go out and read local state for any contract in Algorand for that user, just like I can read their asset balance or their balance, and I can read their any asset balance that they have in any particular asset on Algorand. And the one caveat to this is it's a read-only operation. You can't go modifying local state for another contract. You can only modify it for your particular contract. So that's the difference between those two. And that's why passing in the accounts array is very important. And it's very simple to do, either with Goal or the SDKs. In the demo that one of the demos I have, I pass in the some accounts as well. All right, so let's move it along. And like I said, you can also use Python to build all of these, and this looks similar to this. This is a piece of Python, and if you look at it, it has three condition strings: is payment, is single transaction, is correct receiver. And all I'm doing is using the PyTeal library to say transaction type enum equal to transaction type dot payment, right? And so that we have that. If you look at the PyTeal documentation, all of those types are defined, but then you can say global, which gets me access to all my global variables, global dot group size equal int1, meaning I'm only expecting one transaction. Is it correct receiver? So that's transaction. Give me a transaction property dot receiver, and then I'm saying equal adder. Adder is the pseudo operator for converting a passed-in variable to an address, right? And you can see that those three are all ANDed in the second set of conditions here. Is payment, is single transaction, is correct receiver. Those are all ANDed, and that's what I'm returning. Here's the main program, the running of that program. So we say bank for account, which is this function. This is the address I'm interested in. Compile that program, and this is written specifically for a delegate or escrow, stateless contract. All right, when I run that program, it produces that TEAL. And so the this entire library is shown in the all described in the developer documentation here. If you look in the this is where all the documentation are. There's plenty of examples and stuff like that you can look at. There's also a link on the main Algorand developer site to PyTeal, so you can find it there as well. All right, so let me just run a real quick PyTeal demo to show you. Here is PyTeal test. This is a bunch of different conditions, basically the same kind of code you got. And then I'm also checking the global zero address to make sure that these are the checks that I talked about for safety purposes. And also making sure someone's not spoofing my transaction fee too high, things like that. So this is basically that program. If I run Python 3 PyTeal test.py, you can see this outputs my TEAL, which you can just then pipe directly into your SDK or whatever you're using, or if you're going to use Goal to actually run that particular TEAL code. Okay, let's go back to that. All right, so okay, so these are some of the, please follow these guidelines. It's for your safety and protection. We have a boilerplate approval program. You can take a look at that. We have an example stateless contract. Definitely look at those two. And then adhere to these guidelines. This is most important that you read these and understand these. And then we also have limitations on the size and opcode cost in each one of them. You can't just write a massive program with endless amounts of processing. These are all done to maintain our transaction speed and throughput capability. So that's why these limitations are placed on our smart contracts. So there's a link to this. This whole presentation is available at this location. So I'm going to leave this on there for a second. If somebody wants to just take a screenshot, grab or something like that. And all the examples are also in that DevRel demo directory. So feel free to look at that, and the slide deck is also there as well. So the last thing I'll say is please join our Discord channel. If you don't want to write that link down, just go to the developer website, go all the way down the bottom. There's a little icon for Discord you can click on and join. Please join us there. Our developer documentation is developer.algorand.org. use our forums. We like the forums because it lets our questions be searched and people, it's a historical way of finding answers. So it's kind of one of the reasons why I like people to use the forums. And then obviously there's our GitHub location. And what I would love for you is to join our sign up for office hours. We're going to be doing these roughly once a week, something like that. The next one will be next Monday at 9 o'clock. Ryan will be running that one. We'll be covering how to use the sandbox environment. So make sure you sign up for that and join us at that. So with that, I think I am finished for today. So I'll go ahead and stop showing my screen. Ryan, did we get questions?
Yeah, we got lots of great questions, and we've got one that I wanted to see from Jarnell. He was asking a little bit about the Algo SDK constants not having an attribute. So let me see if I can bring him up online and unmute it so they get the question, because I wasn't sure if the question got answered here. So if I unmute, let's see if this works. It doesn't. All right.
Nice. Wait, read off this question. Let me see if I can.
All right. The module algo-sdk.constants has no attribute number additional bytes after signing. And this was during the call to transactions.payment transaction. So if I could figure out how to unmute this microphone. Yeah, unmute. Okay, so Janelle, I unmuted your mic. Let's see if you happen to have a microphone and can maybe ask the question now to Jason.
Yeah, so hi Ryan, hi Jason. So basically it's a very simple. I have two accounts, and I'm just trying to send some algos from account 1 to account 2. I'm passing the required information as mentioned in the forum as well, and when I'm just doing the transaction.payment, so at that point in time it's giving me this error.
Can you post, Jarnell, you're on Slack with me, right? I mean, on Discord with me, right?
Yeah.
Yeah, can you post a code in the Slack? I mean, no, Discord, I mean, Discord.
Okay.
Yeah, and let me take a look at that. And are you going to be on the encode call shortly?
Yeah, Phil will be there, I guess.
Okay, well, so I may, if you paste that code, I'll find out what the error is and get right back to you. We got to, as soon as this call's over, we got to be on that call, but I'll get an answer to you. So make sure we can figure out what's going on with that error.
Yeah, okay, sure.
It'd be nice if you can just paste your code to me. I'm on a PM with you right now, I think. Just paste your code into into that PM with me, and then I'll work and get you the answer to it.
I'm gonna send it on Discord right now.
Yeah. I'll ping you here so you can see me. I just pinged you on Discord.
Okay.
So just paste the code there, and then I'll get that as soon as we finish up with the encode call.
Okay, sure. Thank you.
All right. Thanks, Jarnell.
And Jason, when you get a chance, just check Slack. And there's one more question from an attendee there regarding the reusing SHA 256. Allowing programs to use scratch paste. It's under the Jason, Ryan, and Shamir thread.
Oh, is this the one that has to do with PyTeal and how to access that opcode for storing and loading within PyTeal?
The PyTeal issue, yeah.
Okay, let me go back and see who asked that one, because I think we answered it.
Oh, okay.
Let me go back and find who asked that question. PyTeal. I think it was Retkin. So
Ritek Jendel, I think it was.
Okay, let me see if I can find him. in here, and I'm going to unmute the mic, and let's see if they have. Oh, I think they just left. So I think that one was actually answered. So if you raise your hand in the attendees thing, then I can tell who wants to actually ask another question, and I'll try to unmute your mic and we can call in as well.
And just so you know, what the goal is going forward, we're not going to do presentations as long as this. The only reason this one took so long is because it's so much material. But we're going to try to reduce the amount of material and allow more Q&A time where people can ask questions. And we're going to go over specific solutions on how to build specific things. So we can get into more nitty-gritty details about what opcodes do what and things like that.
So I don't see anybody raising their hand right now, and I don't have any additional questions, but there was one. So you got just a couple of minutes left. There was a question about decompiling a program.
Yep.
And are you able to do that off the cuff, Jason? Are you able to use Go Clerk decompile to take to take a base 64 string and write it to a file and then show how it decompiles out?
Yeah, I can't. I'm not prepared to do that on a demo. I'd have to write that.
Yeah,
but I think go ahead. Let me see something.
So why, Jason?
So you could do for like an escrow, you can do Go Clerk compile minus uppercase D, which is a disassemble, which disassembles a compiled program. So you can do that. Now, I'm not certain. Do we have a command for that on the SDK, Ryan? I know you can do it in Go. Just use the uppercase minus D. So I'll type it in chat.
Yes, correct. And that's how I answered the question as well. But yeah, with the SDK, I'll be honest with you, I'm not sure if
if you run the dry run, it does give you the disassembled bytecode. Look at debugging smart contracts here. Is my screen still showing? I think it's not.
No.
Okay. Yeah, just go to Ryan. If you want to share yours, just go to if you go to the website, you can go Explore Features, Smart Contracts. There'll be a category Smart Contract Debugging. If you look at using dry run for debugging category, underneath there, you'll see that when you run it, it has a disassembled version in that particular REST command. So it's the I'm trying to remember what the actual REST. It's dry run request is the REST API call. So just read over that particular using dry run for debugging a TEAL program, and you can get the disassembly that way. Okay.
Good. Well, let's wrap it up. Reminder: next Monday, again at 9 a.m. Eastern, I'll be hosting, and we'll talk about the sandbox environment. So we'll get prepared to learn how to spin up an environment very quickly. We'll have more time for Q&A. Go to the forums to sign up. You can go to algorand.com/developers to sign up for this one, the upcoming one, and all future ones as well. Use the forums. Give us some feedback. This is our first one, and we'd love to learn how we can improve it as well going forward. So thanks everybody for attending.
Thanks for joining us, and we'll see you next week.